Hi everyone, welcome to goclasses. In this lecture, we are going to solve GATE previous year questions and some standard practice questions for the topic 3 address code, triples, control flow graph. So let's start this practice and GATE PYQ session. Take your copy pen. Let's solve all the questions together. Me and you together. Let's solve. Let's solve this Ullman book exercise question. Translate the arithmetic expression into syntax tree, quadruples, triples, indirect triples. Remember quadruples, triples, indirect triples. These concepts we have seen in the previous lecture. These are the implementations of three address code by the compiler. The compiler can decide which implementation to choose. Okay, which implementation to use. Now, so this arithmetic expression is given to us and we need to translate this to these representations. Okay, so let me write this arithmetic expression, that is a plus minus b plus c. Here you can notice that this is the unary minus. Okay, this is the unary minus and this is our expression. So now let's see what will be the abstract, what will be the syntax tree. The question is, first the question is asking for syntax tree. The concept of syntax tree we study in the parsing. There is a parser, parsing syntax analyzer. Okay, so in that phase we study the concept of syntax tree, but this is basically very similar to the parse tree. Okay, and the parse tree concept we also study in the theory of computation subject, right? Okay, so let's make the syntax tree for this. Syntax tree is basically very simple. How this arithmetic expression will be evaluated. Okay, so you can see that first we are going to perform b plus c. Okay, so you can see that we will make a node for plus. Okay, basically first we are going to do b plus c. Okay, so like this. So we are making the syntax tree and this is very similar to parse tree, or I can say this is basically a reduced version of parse tree. Okay, a simplified version of parse tree. So you can see that first we will do this b plus c, so plus, and basically these are the operands. Now after the next, you can see after b plus c, this is the unary minus. Okay, so I can make this unary minus like this is the unary minus. Then again we are going to do the addition. Okay, so this addition we are going to do, one operand is a and another is this result of this unary minus. Okay, so that's it. So this is your answer. This is the syntax tree, very simple. Now let's see what will be the three address code. Remember the question is asking quadruple, triple and indirect triple representation. So first you find the three address code. Okay, right now this statement we have in the high level language, right? Correct? Yes or no? This we have in the high level language. First you convert this to three address code. Okay, so let's see what will be the three address code for this statement. First, we will do this b plus c. So I can store this in the temporary variable t1. Okay, so t1 equal to b plus c. So I'm writing the three address code corresponding to this high level language statement. Okay, so very simple, t1 equal to b plus c. Then we have this unary minus. Okay, so I can say t2 is equal to unary minus t1. Okay, very simple. Next, we have this addition. Okay, so I can say that t3 is equal to a plus t2. Okay, yes or no? So remember, this will be the three address code. Now let's represent this three address code using quadruples, triples and indirect triples. Okay, so first let me represent this three address code using quadruples. What will be the quadruple representation? So let's see the quadruple representation for this high level language statement, or I can say for this three address code, what will be the quadruple representation? In the quadruple representation, I told you what is quadruple. In this representation, basically this representation is a array of records. Every record has four fields. Okay, so in the quadruple representation, to represent, to store any three address code instruction, we use four field. What are the four field? Operator, argument 1, argument 2 and result. Okay, yes or no? Very simple. So this is the quadruple representation. In the quadruple representation, to store any three address code instruction, we use total four field. These are the four field. Okay, now you can see, let's store this first instruction t1 equal to b plus c. So tell me, in the quadruple representation, how are we going to store this t1 equal to b plus c? Very simple. Here, what is the operator? The operator is plus. Okay, here you can notice this is the operator. Operator is basically plus. Okay, you might be thinking that this assignment is also operator, but I told you in the previous lecture when we were discussing three address code, quadruple, triple, all these representations, when we were discussing, I told you that the operator is basically plus, and this assignment is implicit. Okay, this assignment, this is a implicit, or I can say this is implied. Okay, so you can say this is implicit or you can say this is implied. So remember, for this instruction, for this first instruction, the operator is basically plus. Okay, very simple. And what is the argument 1? Argument 1 is b, argument 2 is c, and the result, that is t1. Okay, so b c t1, very simple. Okay, and I can say this is the position 0 because I told you what is this quadruple. This quadruple is basically array of records. Array of records. Okay, and remember, in every record, array of records, and in every record has total 4 field. These are operator: argument 1, argument 2, result. Very simple. So you can see this is the position 0, position 1, position 2. Okay, now let's see for this next instruction how to store in the quadruple representation. Very simple. Here the operator is unary minus. Okay, so I can say u minus. So I'm using this u minus word for unary minus. When you have unary minus, then I'm using this word u minus to denote unary minus. Okay, and when you have binary minus, like for example a minus b, 5 minus 4, something like that. So you can see when you have binary minus, then for that we can directly use this symbol, this subtraction symbol we can use. Okay, so you can see in this instruction the operator is unary minus. Tell me, what is the argument? Argument, there is only one argument. Okay, that is t1. This is the argument 1. There is no argument 2. You can leave it empty. And what is the result? The result is basically t2. Okay, very simple. What about the next instruction? For the next instruction, the operator is plus. Arguments are a comma t2. These are the arguments, and the result will be t3. That's it. So this is the quadruple representation. Very easy. I hope you understood. Now let's see what will be the triple representation. In the triple representation, we use three field. What are the three field? These are operator, argument 1, argument 2. Basically, in the triple representation, we do not have the result field. Okay, remember in the quadruple representation, we have result field also. And in the triple representation, we do not have any result field. Very simple. Okay, so this triple representation, this is also array of records, and every record has three field. Okay, so this is also basically array of records where every record has three field. Okay, now let's see, these are the positions or indexes 0 1 2. Okay, these are the indexes. Now you tell me, for this instruction, how to store this in the triple representation? Very simple. The operator, that is plus. Okay, argument 1, that is b, argument 2, that is c, b comma c, that's it. Okay, remember there is no result field, and we do not store the temporary variable in the triple representation. We do not store the temporary variables. Very simple. Okay, now let's see the next statement. In the next statement, in the next instruction, the operator is basically unary minus. This is the operator. And what are the arguments? You can see the argument is t1, but remember, in the triple representation we do not have any t1. We do not store any temporary variable. Now notice one thing, this t1 means the result of this operation, yes or no, b plus c. So in the quadruple representation, notice that the result of b plus c, that result we refer by the temporary variable t1. In the quadruple representation, the result of this operation b plus c, that result we refer by the temporary variable t1. But in the triple representation, the result of this operation b plus c, we do not refer by the temporary variable, but we refer by the position. Okay, so to refer to the result of this operation b plus c In the triple representation, we do not use any temporary variable. We refer to the result of this operation by the position. Okay, so very simple. You can see in the second instruction, the operator is basically unary minus, and T1 means the result of this operation. And in the triple representation, to refer to the result of this operation, we use the position. Okay, so very simple position like this. And you can see there is no other argument. Okay, there is only one argument, there is no argument 2, and we do not have any result column. Okay, and also we do not store the temporary variables. Very simple. Okay, now let me tell you one more thing, why I am putting the parenthesis here. I told you in the previous lecture also, when we were discussing triple representation, quadruple representation, all these things, I told you that we use this parenthesis to to denote that this is the position, this is not the constant. For example, if I directly write 0, it will be the constant. If I directly write 0, it will be the constant. And if I put the parenthesis, it simply means I am referring to the position. Okay, very simple. Now let's see what about the next instruction. The operator is plus, one argument that is a, another argument that is t2. Okay, but remember in the triple representation there is no such thing as t2. Now t2 means the result of this operation, yes or no? And remember in the triple representation, to refer to the result of this operation, we use position. We do not use the temporary variable, we use the position. So basically this t2 simply means the position 1. Okay, the position 1, very simple. So that's it, this is the answer. I hope you understood. Now let's see what about indirect triple. We have seen the triple representation. Now let's see what will be the indirect triple representation. And I told you what is indirect triple representation. The beautiful definition of indirect triple representation, that is indirect triple representation. This is similar to the triple representation, but in the indirect triple representation, we separate the triple and the execution order. Okay, remember in the triple representation, this order of triples, this is the execution order. Okay, yes or no? If you remember, I told you in the previous lecture that in the triple representation, the order of triples, this itself is the execution order. The order of triples, that is same as the execution order, or I can say execution order is same as the order of triples. But in the indirect triple, what we do, we separate the execution order from the triples. So remember, triples will be as it is. Okay, is this clear? Remember, these triples will be as it is. But what we do, we separate the execution order from these triples. Okay, so we also need to put the execution order. So here, what I'm going to do, notice, I'm also going to put the execution order. So notice one thing, that triples are as it is. These are the triples. Triples are as it is. But in the indirect triple, we have two things. What are the two things in the indirect triple? One is execution order, and the second is triples. Triples we have already found, these will be as it is, but we have an execution order. Okay, so let me put here execution order. So to denote the execution order, we use another array of pointers. Okay, so this array of pointers, we can call it instruction list. You can call it instruction list, instruction sequence, or you can call it program. Okay, or some people call it program list, basically program sequence. Okay, or you can simply call it that this is the execution order. This is simply the execution order. Okay, so remember in the indirect triple there are two things, execution order and triples. Triples we have already found, these will be as it is, and the execution order is separate. Okay, so what will be the execution order here? If we are not making any changes to the execution order, execution order will might be changed, may or may not be changed. Execution order might be changed during optimization. During optimization, if you want to change the execution order, then you can change it. But here in this particular question, there is no discussion of changing the execution order, yes or no. There is no such discussion, so we can directly say that execution order is basically 0 1 2. That's it. Okay, means what it means, remember here 0 1 2, what it simply means, it simply means that this is basically a pointer to this triple, this is a pointer to this triple, this is a pointer to this triple. Okay, is this clear? And remember, this execution order, or I can say this instruction list, this is also an array of pointers, this is also an array. Okay, so it's like 0, 1, 2. This is also array, and in this array we have pointers which point to the triples. So that's it. So this is your answer for indirect triple. Very easy. Okay, so to find the indirect triple representation, first you find the triple representation, and then what you do, you just separate the execution order from the triples. Okay, so triples are separate, execution order is separate, and by default the execution order, by default, if you are not making any changes to the execution order, then by default the execution order will be same as the order of triples. Okay, very simple. But if you want to make any changes to the execution order, then you don't have to make any changes to the triples, you just have to change this execution order. This is the benefit of indirect triples, that we have separated execution order from the triples. Okay, so during the optimization phase, if you need to move around the instructions, if you need to make any changes, if you need to rearrange the code, then that is very easy in the indirect triples. So this is the answer. I hope you understood. Let's see a note, that is quadruple triple representation for the following three address code instructions. These are the three address code instructions, and for these three address code instructions, what is the quadruple representation, what is the triple representation? So let's discuss this. Okay, let me tell you that these are called indexed copy instructions. I told you when we were discussing three address code, I told you that in the three address code we have indexed copy instructions. Okay, what is the meaning of these instructions? Let's do the revision, or I can say recap, because we have already seen. You can watch the previous lectures where we were discussing three address code instructions. What is three address code, what are three address code instructions, what instructions are allowed. Okay, so there we have already seen these indexed copy instructions. Okay, so basically these are the two instructions. One instruction is x equal to yi. Okay, what is the meaning of this instruction? This is a three address code instruction, this is allowed in the three address codes. And what is the meaning of this instruction? This instruction simply means that in x we are putting the value, we are putting the value at location. At which location? In x we are putting the value, we are storing the value at location y plus I. Okay, so remember, at this location y plus I, at this location, the value that you have, that value you store in x. This is the meaning. Okay, very simple. So you can read this. The instruction x equal to yi, this will set x to the value at which location? At the location y plus I. Okay, very simple. And what about this instruction? That is xi equal to y. Okay, so we are assigning the value of y here. So what is the meaning here? Okay, remember this xi, basically this is a location. Okay, which location? X plus I. At that location we need to put the value y. Okay, so please understand here, it means that put, or I can say store value y, store value y at location. At which location? At location x plus I. This is the meaning. I hope you understood. So you can see the instruction xi equal to y. This will set the content at this location x plus I to the value of y. Okay, so very simple. So you can see we will store the value of y at this location x plus I. Okay, so these are called indexed copy instruction in the three address code we have already seen. Now the question is, what will be the quadruple representation? What will be the triple representation for these three address code instructions? Okay, for these indexed copy instructions, what will be the quadruple and triple representation? So let's see that. Let me tell you that these instructions, they require two entries in the triple structure, also in the quadruple structure. So remember, to store this instruction or to store this instruction in the quadruple or triple representations, you need two entries. Okay, is this clear? So you can notice that these instructions, they require two entries in the triple or quadruple structure. It will become very clear. So let me tell you one more thing, that you can notice that in this instruction, this indexing, this is on the right side, and in this instruction this indexing is on the left side. Yes or no? So let me tell you that to distinguish this indexing is on the left or right, to distinguish that we use two separate operators. Okay, so let me tell you that Here, which operator we are going to use? Okay, see, you can easily notice here the operator is basically this. You can notice that if I write this x something xi, now here you can notice that operator, in the operator I will put this. Okay, very simple. Okay, so these brackets I will put in the operator. So this is the operator. But I told you that there are two situations. Either this indexing, either this operator can be on the right side, okay, or this operator can be on the left side. Okay, so you can notice that to distinguish whether this operator we have on the left or right, to distinguish that, what we use two separate operators, or I can say two separate symbols we use. So you can notice here, because this operator, or I can say this indexing is on the right side, so let me tell you, here we use this symbol. Let me write it here, we use this symbol like this. Okay, is this clear? So you can notice that here we use this symbol. Okay, it simply means that this operator, or I can say this indexing is on the right side. Is this point clear? Is on the right side. And here, to denote that this operator, or I can say this indexing is on the left side, which operator we use? We use the operator like this. I hope you understood. Is this point clear to everyone? Notice one thing, that if you look at this, to store this in the triple representation or quadruple representation, you might be thinking that yes, operator is basically this bracket is the operator. That is right. But let me tell you that this operator either can be on the right side, or this can be on the left side of the assignment. Okay, you can see right side of the assignment, you can see left side of the assignment. So to distinguish this, we use two different symbols, or I can say two different operators. You can notice, when this operator is on the right side of the assignment, we use this symbol. It simply means that this operator is on the right side of the assignment. And when this operator is on the left side of the assignment, we use this symbol to denote that this operator is on the left side of the assignment. Okay, is this point clear? Now let's see one by one what will be the quadruple and triple representation for these two instructions. Okay, so first let me discuss this instruction x equal to yi. Okay, so this is our indexed instruction, indexed copy instruction. Now let's see what will be the quadruple and triple representation for this three address code instruction. Remember, this is allowed in the three address code. We have already seen that this instruction is allowed in the three address code. Okay, now, this instruction will require two entries in the triple and quadruple representation. Okay, so let's see what will be the quadruple representation and what will be the triple representation. Okay, so let me tell you what are the two entries. First of all, let me discuss what are the two entries. Here you can notice we have x equal to yi. So actually this will require two entries. What are the two entries? The first entry is basically that first we will put t equal to yi. Okay, means first we will store in the temporary variable. Okay, so you can notice in some temporary variable we will store, and then x equal to t, then this temporary variable we will store in x. That's it. Okay, very easy. Now let's see what will be the quadruple and what will be triple representation. So first let me tell you about the quadruple representation, and then we will also see the triple representation. Both are very easy. Okay, but remember, in the quadruple and triple representation, if you want to represent or if you want to store this instruction, this three address instruction, then remember we need two entries. Okay, first we will store in a temporary variable t equal to yi, and then x equal to t. Okay, very easy. Now let's see what will be the quadruple representation. In the quadruple representation, we have four field operator, argument 1, argument 2, result. Okay, yes or no? And in the triple representation, we have only three field operator, argument 1, argument 2. Okay, very simple. Now, in the quadruple representation, remember, to refer to the result of any operation, we use temporary variables. Okay, and in the triple representation, to refer to the result of any operation, we use the position. Okay, in the triple representation we do not use the temporary variable. Okay, so you can see in the quadruple representation there are four fields. Now let's see for this instruction how to store in the quadruple representation. Very simple. Tell me what is the operator. Now you have already understood These two instructions we need to store in the quadruple representation. So tell me how to store this first instruction. The operator you already understood. That operator is basically assignment and then this, then bracket, assignment bracket. Why? What is the reason? Because you can notice that this operator is on the right side of assignment. Okay, so remember like this. Very simple. That this operator is on the right side of the assignment. And tell me what is the argument 1, argument 2? Argument 1 is y, argument 2 is I. Okay, y comma I. These are the argument 1, argument 2. And what is the result? The result is t. That's it. Very easy. Okay, so this is the quadruple representation for this statement. Let's see what about this statement. This x equal to t, I told you, if you remember, that this is a special. Why this is special? Because here this assignment itself is the operator. There is no other operator other than this assignment. So here you can notice that the operator itself is assignment. Okay, yes or no? But remember, look at here. Here the operator is basically this bracket. You might be thinking this assignment is also operator, but I told you in the previous lecture also, when we were discussing triple comma quadruple, I told you that this assignment is implicit. Okay, but remember, when this assignment is the only operator, when it is the only operator, then operator will be assignment. Okay, and when you have some other operator also, in that case this assignment will be implicit, or I can say implied. Okay, so now let's see what about this x assignment t. So here the operator is assignment. Okay, and you can see what is the argument. The argument is t. There is no second argument, and the result is x. Okay, so that's it. So this is your answer for the quadruple representation. Now let's see the triple representation. Okay, so for this first statement, what will be the triple representation? The operator you already know, that is assign bracket, because this bracket is on the right side of the assignment. So this is the operator. Okay, what are the arguments? Argument 1, argument 2, these are y comma I. Argument 1, that is y. Argument 2, that is I. Okay, and remember, there is no result field here. Also, we do not store the temporary variables in the triple representation. So very simple. So that's it. Now what about this x assigning t? In the triple representation, I already told you that this is a special instruction. In the triple representation, the operator will be assignment. Okay, and remember, this x will be the argument 1. Okay, this we have already seen in the previous lecture. I told you that this is basically, whether you discuss quadruple or whether you discuss triple, this is basically a kind of a special instruction. Okay, so you can see in the triple representation how to store this instruction. Very simple. The operator is assignment. The argument 1 will be x, and the argument 2, that will not be t. Okay, because remember, in the triple representation there is no such thing as t. There is no such thing as temporary variable. You can see what this t means. This position 0, yes or no? These are the positions 0 comma 1. So remember, this t, when you want to refer to this temporary variable t in the triple representation, we will refer by the position. Okay, so here I should put this position. Okay, is this clear? Very simple point. In the triple representation, if you want to refer to the result of any operation, then we do not use temporary variable, we refer by the position. Okay, so you can see that this t in the triple representation, this t simply means this position 0. Okay, so this will be your answer. I hope you understood. So remember, for this 3 address code instruction, this is the quadruple representation, this is the triple representation. I hope it has become very clear. Okay, now let's see how to represent this next indexed copy instruction in the quadruple and triple representations. So you can see this is another indexed copy instruction. Here you can see we have xi equal to y. Basically here indexing, or I can say this operator, this bracket is basically on the left side of the assignment. Okay, what is the meaning of this instruction? That we already know. We have already seen that this instruction xi equal to y, what this will do? Here we are storing the value of y at the location x plus I. Yes or no? Okay, the value of y we are storing at the location x plus I. Very simple. So remember here what we are doing, we are storing the value of y at location x plus I. Okay, this is what we are doing here. Very simple. Now let's see in the quadruple and also in the triple, what will be the representation for this? So let's see this instruction in the quadruple and triple representation. This instruction will also need two entries. So let me tell you what are the two entries that this instruction will need. Here, notice one thing. First, we need to calculate the location. Okay, notice that we are storing this value of y at the location x plus I. Okay, so notice that for this three address code instruction, we need two entries in the triple and quadruple structure. What are the two entries? This is what I'm explaining. So notice that first we need to compute the address. Okay, the location. Because remember, this value of y we are storing at some location, and that location is x plus I. Yes or no? So the two entries that we need, those two entries are like this. First, we will compute the address xi, and then we will store the value of y at that address. Okay, is this clear? So now let me write it here that the first entry will be like this, that first we will calculate the address, okay, the location, because at the location x plus I, at that location this value of y we want to store. Okay, so remember what we are going to do. First, this xi, this location, basically we are going to find, and we will store it in some temporary variable t. Okay, in some temporary variable t we are going to store it. Then what we will do, then in this t we will store the value y. Okay, so that's it. I hope you understood this point. Is this point clear? Now let me tell you one thing here. You might be thinking why I am writing like this. See, what is the reason I'm this first, this, look at this first line. Why I am not writing like this, that t equal to xi? Why not this? Basically I am saying that we will calculate the location. Okay, we need to compute the location, we need to compute the address, and we need to store it in some t. So now this t has this location. Okay, t has the location. Is this point clear? Now I am saying that I am writing like this, I am not writing like this. What is the reason? Because if I write like this, then you will get confused. Then you will use this operator, but actually what operator we need to use? We need to use this operator. Yes or no? Is this point clear? Are you getting my point? What I'm saying? I'm saying that look at this, compute the address of xi. Okay, you compute the address of xi and you store it in the temporary variable t. Now this is very easy to understand what I'm saying. But if I write this same thing, if I write like this, okay, then remember there will be a confusion. It's nothing actually, but there will be a confusion, because here you can notice this we have already seen, and this was basically for when this operator, this bracket is on the right side of the assignment. So I don't want to confuse you. That is the reason I'm not using this, I'm using this, because I don't want to confuse you. Okay, is this point clear? So understand that for this instruction, for this three address code instruction, we need two entries in the triple and quadruple structure. The two entries are like this. The reason is very simple, because this value of y we are storing at the location x plus I. So the first entry is basically compute the address of xi. Let's store this in the temporary variable t, and then in the t at this location you store the value y. Okay, so very simple. Now let's see what will be the quadruple and triple structure. Okay, so now let's see the quadruple and triple structure. So I'm writing here the quadruple structure, and here I will write the triple structure. Okay, now you can easily answer it. So just tell me what will be the quadruple structure, what will be the triple structure. Argument 1, argument 2, and result. And in the triple representation, we have operator, argument 1, argument 2. Okay, so tell me, what about this first one? You tell me for the first one. You can see these are the positions 0, 1. These are the positions 0, 1. Okay, so you can see the first entry. What will be the first entry in the quadruple representation? That is quite easy. What will be the operator? Tell me what will be the operator? Operator will be bracket, then assignment. Yes or no? Because remember here, this is the instruction that we want to represent. Okay, and here you can notice that this indexing, or I can say this bracket, is on the left side of the assignment. So you can see this bracket is on the left side of the assignment. Is this point clear? So this will be the operator. Now what is the argument 1, argument 2? Look at this first entry. Only look at this first entry. So what is the argument 1, argument 2? Argument 1 is x, argument 2 is I, and where I am storing the result? I am storing the result in t. Okay, we are storing the result in a t. That's it. Now what about this next one? This is very easy. So here the operator will be assignment. Assignment is the operator. And what is the argument? Argument is y. There is no argument 2, and the result is basically t. Okay, so this is the quadruple representation for these two entries, or I can say this is the quadruple representation for this instruction. I hope you understood. Now let's see the triple representation. In the triple representation, tell me what will be the operator? Operator you already know, that is bracket then assignment, because you can see this bracket is on the left side of the assignment. Okay, so you can see bracket assignment, this is the operator. Tell me for this entry, for the first entry, what are the arguments? Arguments are x comma I. Very simple. And remember, there is no result field in the triple representation. Also, we do not store temporary variables. If you need to refer to the result of any operation, then do not use the temporary variable, use the position in the triple representation, that we already know. Okay, now let's see this t equal to y. In t we are assigning y. So tell me, in the triple representation, what is the operator? That is the assignment. Assignment is the operator. And remember, in the triple representation, this t, this t we put in the argument 1. Yes or no? I told you this we have already seen just in the previous example also, and also in the previous lecture. So you can see this is the special instruction, this is the assignment instruction. Okay, this is the special instruction. Here the operator will be assignment, and next notice this will be the argument 1. Okay, this t, this is the argument 1, and argument 2 will be y. Argument 2 will be y. But remember, in the triple representation there is no such thing as t, or I can say temporary variable. So to refer to the temporary variable, we use the position. Okay, so just use the position. So that's it. So this is the triple representation. This is the quadruple representation for this instruction. I hope you understood. Is this clear to everyone? Please tell me. Let's see this example. Tell me, for this example, what will be the quadruple representation and what will be the triple representation? Notice one thing. Here we have temporary variable. Okay, so please understand, this itself is the temporary variable. This itself is the temporary variable. Okay, so tell me, what will be the quadruple representation? What will be the triple representation? Here you will only need one entry. Okay, here you need only one entry. Okay, so let's see what will be the quadruple representation and what will be the triple representation. So quickly tell me, quadruple representation has 4 field: operator, argument 1, argument 2, and result. Okay, and triple representation has 3 field: operator, argument 1, argument 2. Okay, so let's see. Here you can notice, in the temporary variable t, we are putting the value at the location y plus I. Okay, so here which operator? First, to tell me which operator. Here you can notice this bracket, or I can say this indexing, this index copy instruction. Here this bracket is on the right side of the assignment. Okay, so here this is the operator we are going to use. Very simple. What are the arguments? Argument 1, argument 2, those are y comma I, y comma I, these are the arguments, and the result is stored in t. Okay, in the quadruple you can write t in the result. Very simple. What about triple? In the triple, the argument 1, argument 2, these are y comma I, that's it. Okay, you can see in the triple representation we do not have any result field, so also we do not store the temporary variables. Okay, so this is the answer. Let's see this. Here you can notice that we have temporary variable here. We have temporary variable here. Now tell me, what will be the quadruple and triple representation? Tell me how many entries we need for this instruction. Here you can notice we have temporary variable here. So how many entries we need? Think about it. Let me tell you, here we need 2 entries. here again we need two entries, because please understand that when we were having xi equal to y, at that time also the first entry was basically computing the address, or I can say the location. Yes or no? Here also you can notice that at this location we need to put the value of t. At the location x plus I, we need to put the value of t. So when we were having xi equal to y, then also the first entry was basically what it was doing. It was basically finding, computing the value of address, or I can say the location basically. It was computing the location or address. Yes or no? So the same thing we need to do here also. Operator, is this point clear? Operator, argument 1, argument 2, and result. Okay. And in the triple we have operator, argument 1, argument 2. So notice that when we were having xi equal to y, then also before storing this value, this right side value, before storing this right side value to the left side value, or I can say to the left side location, first we need to compute this location. Yes or no? So remember here again we need two entries. The first entry will basically compute the location. Okay. And that location let's store in some temporary variable, let's assume t1. Okay, so remember what is the operator here? The operator is bracket assignment. Okay, then you can see what are the arguments. The arguments are x comma I, and let's store in some temporary variable, some, let's assume t1. Okay, is this point clear? Basically I told you that here we need, again we need two entries, entry 1 and entry 2. Okay, so in the entry 1 what we are going to do, again we are going to compute the location first. Okay, we are going to compute the location first. And when I say compute the location, basically what you do, basically this location you store in some temporary variable t1. And then this entry 2, what this will do, in this entry 2 basically this is what you are going to do. So notice that here I can say first you compute the location, you store that in some temporary variable t1. And now this is very simple assignment operator. The argument 1 is basically t, there is no argument 2, and the result is basically t1. Okay, very simple. Yes or no? So this is the quadruple representation. What will be the triple representation? The operator you already know, the bracket, then assignment. This is the operator. What are the arguments for this computing location? First we are computing location. So what are the arguments? Arguments are x comma I. There is no result field, we do not store the temporary variables. Very simple. Okay, let's assume that here the location is 0 or some location, let's assume position, let's assume position is 4. Okay, let me assume position is 4. Now at the position 5 what we need to do, t1 assigning t. So you can see the operator will be assignment, and here you can see that this will be the argument 1, t1. Okay, t1 will be the argument 1. So tell me what is t1 here? T1 is basically this position 4. Yes or no? This position 4, this is basically your t1. And what is the argument 2? That is t. Argument 2 is t. Okay, let's assume the position of t is 2. Okay, I am assuming that position of t is 2. Okay, this what I have assumed. There will be some position, yes or no? So you can notice that. Let's assume position corresponding to t is 2. Assume position corresponding to t is 2. Okay, is this point clear? So this is how you will do. I hope you understood. So that's it. We have seen for the indexed copy instructions, there are two instructions which are indexed copy instructions allowed in the 3 address code. For both of them, what will be the quadruple representation, what will be the triple representation? I hope you understood this. Whatever we have seen that is written here also, so you can read this, but we have seen in a very detailed way. Okay, this is very brief, I can say brief explanation of whatever we have seen. Okay, now let's solve Ullman book exercise questions. We need to repeat exercise 6.2.1. Basically this exercise 6.2.1 we have already seen. Okay, just the first question in this session, that was exercise 6.2.1. Okay, that we have already done. Basically some arithmetic expression was given, and for that expression we wanted to find different representations. We wanted to translate this arithmetic expression into some different representations. Okay, now let's see this question, that for these two instructions we need to find what will be the quadruple, triple and indirect triple representations. Okay, so let's see this. So let's see the first one. For this instruction, what will be quadruple, triple, and indirect triple representation? So let's see. This is the instruction that is given to us. This is in the high level language. If you want, first you can find the three address code. Okay, that will be easier way. So first you can find the three address code corresponding for this instruction. This is in the high level language. So what will be the three address code? Tell me. The three address code is very simple. In some temporary variable t1, we are going to store bi. Then in some temporary variable t2, we are going to store cj. Then in some temporary variable t3, we are going to do t1 plus t2. And then we are going to a equal to t3. Yes or no? Is this point clear? So remember, this is the three address code corresponding to this high level language statement. This is in the high level language. Okay, so first we have converted to three address code. Now let's see this three address code. Let's represent in the quadruple, triple, and indirect triple. So let's see what will be the quadruple representation. In the quadruple representation, we have four field: operator, argument 1, argument 2, and result. Okay, so here you can notice these are the entries: position 0, position 1, and so on, position 2, position 3. So let's see. Tell me, corresponding to this instruction, what will be the entry in the quadruple representation? Here you can notice what is the operator. You can notice the operator is basically this bracket on the right side of assignment. Okay, yes or no? This bracket on the right side of assignment, this is the operator. Next, what are the arguments? The arguments are b comma I. These are the arguments. And the result we are storing in t1. Very simple. What about this next statement? Here, this is c. Okay, so what about this next statement? Here you can see what the operator. Again, the operator is assignment, then bracket, because this bracket is on the right side of the assignment. So you can see this bracket is on the right side of the assignment. Next, the arguments are basically c comma j. These are the arguments, and the result we store in t2. Very simple. What about this next? The operator is basically plus. The arguments are t1, t2, and the result we are storing in t3. Very easy. Then what about this instruction? Here the operator is assignment. Yes or no? Here the operator is assignment, and the argument is t3. There is no argument 2. There is no second argument, and the result will be stored in a. Okay. So this is the quadruple representation. I hope you understood. Now let's see the triple representation. In the triple representation, we have operator, argument, argument 2, argument 1, argument 2. There is no result field. Yes or no? So these are the positions. Remember, by default, the position numbers they start with 0. Okay, the position numbers they will start with 0. So let me tell you one thing. Whenever you find the triple representation, then let me tell you that because you know that position they start with 0, and in the triple representation, whenever you need to refer to the result of some previous operation, then you will refer by the position. Yes or no? In the triple representation, whenever we need to refer to the result of some previous operation, then we will do that by the position number. Yes or no? And the position numbers they start from 0. So let me tell you, this is just a small thing, that these temporary variables that you generate them also from 0 onwards. Okay, then what will happen? Whenever you need to refer to t0, it means you are referring to the position 0. Whenever you need to refer to the t2, then you are referring to the position 2. Are you getting my point? Did you understand this small point that I'm telling you? That for simplicity, or I can say for the purpose of simplicity, or for the purpose of convenience, let me tell you, so that you don't make any mistake, what you do, whenever you find the triple representation, then these temporary variables that you generate, they also you generate from 0 onwards. Okay, like this is the temporary variable t0, this is t1, this is t2. It's a small change, nothing. Okay, it does not make any changes to the three address code. It does not affect anything. Okay, this is just a small thing we do for simplicity, so that we do not make any mistake here. Okay, so you can see it is basically t0 plus t1, like that. Now let's see what will be the triple representation for this instruction. What will be the triple representation? The operator, that is basically assignment, then bracket. Okay, what is the argument 1? Argument 1 is b, argument 2 that is I, and there is no result field. We do not store the temporary variables. That's it. What about this next instruction? The operator is assignment, then bracket. The argument 1 is c, and the argument 2 that is j. Okay, what about this next instruction? Here you can see the operator is basically plus. This is the operator. And what are the argument 1, argument 2? These are T0, T1. But remember, in the triple representation, whenever you need to refer to the result of some previous operation, then we do that by the position. So here remember, T0 simply means position 0 and T1 simply means position 1. Okay, yes or no? Very simple. Now, what about this instruction? Here you can see the operator is assignment now. Okay, and you can see this will be argument 1, this A will be argument 1, and this T3. T3 means what? Sorry, actually, this will be T2. Okay, this will be T2 because we are numbering these temporary variables from 0 onwards. So this will be T2. So you can see the operator is assignment, and you can see this will be the argument 1. And what is the argument 2? Argument 2 is T2. T2 means this position 2. Okay, so that's it. This is the answer. I hope you understood. So this is the triple representation. Now tell me what will be the indirect triple representation. Tell me what will be indirect triple representation. Once you have the triple representation, you can also find the indirect triple representation. In the indirect triple representation, I told you we have two things. One is execution order, another is triples. So remember, triples are as it is. Okay, these triples, they will remain as it is. Whenever you need to find the indirect triple representation, first you find the triple representation, and then you just also put the execution order, because remember, in the indirect triple representation we separate the triples from the execution order. So triples are separate and execution order is separate. Okay, and to indicate the execution order we use an array of pointers, and this array of pointers you can call it instruction array. Okay, is this clear? Very simple point. So this instruction array, remember, this will tell you about the execution order. That's it. Okay, so this is the instruction array, this is the array indexing, and here you can put the pointers to the triples. Okay, for example, here I can say this will point to this triple, this will point to this triple, then 2, then 3. Okay, so they are pointing to the triples. Very simple, that's it. So remember, whenever you need to find the indirect triple, then remember one thing, that in the indirect triple we separate the triples from the execution order. Triples are separate, execution order is separate, and to indicate, or I can say to store this execution order, we use an array of pointers. They will point to the triples. Okay, this is the array of pointers, and this we call instruction array. So that's it. I hope you understood. Now consider this instruction, or consider this statement in the high level language. This statement, this is in the high level language. Now, first, to find the quadruple, triple, and indirect triple representation corresponding to this statement, first you convert this statement to 3 address code. Okay, so let's convert to 3 address code. For this statement, the 3 address code, what it will be? Very simple. T1 is equal to B into C. Okay, so this B into C, this we can store in some temporary variable T1. Then you can notice that T2, that will have B into D. Okay, then you can see T3, what that will be. You can notice this we are storing in T1, this we are storing in T2. Then in T3 we are storing T1 minus T2, and then you can notice that in AI we are storing T3. Okay, for simplicity, let me number these temporary variables from 0 onwards. Okay, see here I'm using them temporary variables from T1 onwards. Let me make them from 0 onwards. Okay, because when I make the triple representation, it will become easier for me, because in the triple representation, the position numbers they start from 0. So that is the reason. Let's do one thing, that these temporary variables, let's make them from 0 onwards. Like we are storing B into C in T0, then T1, then you can notice T2. Okay, T2 is equal to T0 minus T1, and then AI equal to T2. Okay, so this is the 3 address code that we found. Now, after finding this 3 address code, let's see what will be the quadruple representation. In the quadruple representation, we have 4 field. Okay, operator, argument 1, argument 2, and result. So tell me quickly, these are the positions 0, 1, 2, 3, and so on. Okay, these are the positions. So you let me know. For this first instruction, the operator is star, the arguments are b comma c, the result will be t0. For this next instruction, the operator is star, the arguments are b comma d, and the result is t1. Okay, for this next instruction, the operator is minus, the arguments are t0, t1, and the result will be t2. Very easy. What about this last one? We have already seen how to represent this instruction in the quadruple and triple representation. How to do that? Tell me how many entries will be there? There will be two entries. Yes or no? This we have already seen that actually now there will be two entries. So you can see 3 comma 4. So please understand, for this there will be two entries. Okay, in the first entry, what we will do? Tell me. In the first entry, we will compute the location. We basically will compute the address. Okay, and that we can store in some temporary variable t. Okay, so you can notice that there will be two entries. What is the first entry? What is the operator? Operator is basically bracket assignment, because remember this bracket is on the left side of the assignment. Okay, so remember this will be the operator. Now, what will be the arguments? So you can see in the first entry, the arguments will be a comma I. These are the arguments, and the result you can store in some temporary variable t3. Okay, is this point clear? The result you can store in some temporary variable t3. So basically in t3, what we have? This location we have. Okay, this a plus I, this location we have. Now what is the next entry? In the next entry, in this location you will put the value t2. Okay, so you can see the operator will be assignment, because in the second entry basically you are doing this, that t3, in t3 you are putting the value t2. This is the second entry. Yes or no? Okay, so tell me, for the second entry, you can see the operator is assignment. And what are the arguments? The argument is T2. Okay, there is no second argument, and the result, that is T3. Okay, yes or no? That's it. So this is the quadruple representation. I hope you understood. Now let's see the triple representation. In the triple representation, we have three field: operator, argument 1, argument 2. Okay, so these are the positions 0, 1, 2, 3, 4. Okay, these are the positions. Now let's see. Let's quickly see what about this first instruction. Here the operator is multiplication and the arguments are b comma c. What about this next one? Here the operator is multiplication and the arguments are b comma d. What about the next? Here you can see the operator is subtraction, and what are the arguments? Arguments are t0, t1, but remember t0 means position 0 and t1 means position 1. Okay, very simple point. Because in the triple representation, whenever you need to refer to the result of some previous operation, then we refer by the position, not by the temporary variable. Okay, so you can see, very easy. Now what about this instruction? Okay, I already told you in this lecture, previously you can watch. Okay, we have already seen that for this there will be two entries. Okay, what are the two entries? Tell me, what are the two entries? The first entry will be basically we are computing the location. Okay, that we will store in some temporary variable. Let's assume t3. Okay, and then what will be the next entry? The next entry will be that, okay, at this location we are going to put t2. So this is the simple idea that we have already seen. Now let's see what will be the entries. So let's see this entry. Here you can notice the operator. What is the operator? The operator is bracket assignment. This is the operator. Okay, you can see here, because this bracket is on the left side of the assignment, so the operator is basically bracket then assignment. And then you can see what are the arguments, a comma I. These are the arguments. That's it. What about this t3? In t3 we are assigning t2. Okay, so here the operator is assignment. Operator is assignment, and you can see this will be argument 1 and this will be argument 2. So argument 1, that is t3. T3 means position 3, and argument 2, that is t2. T2 means position 2. That's it. This is the answer. This is the triple representation. I hope you understood. Now let's see what will be the indirect triple representation. Once we have the triple representation, we can also find the indirect triple representation. In the indirect triple representation, this triple will be as it is, And also we need to put execution order, because remember in the indirect triple representation we separate the triples from the execution order, yes or no? So this is the execution order. So very simple. In the indirect triple, the triples will be as it is, but separately we have a instruction array. Separately we have this instruction array which will tell you about the execution order. Okay, and remember this instruction array, this is the array of pointers. Okay, so you can see this will point like this. Very easy. So I can say this is the array of pointers. Very easy. I hope you understood this. So that's it. Let's solve GATE 2024 question based on triple representation. This is a beautiful question, and all the concepts required to solve this question we have already seen in this lecture. Okay, so you can watch this lecture from the beginning to learn all the concepts that are required to solve this question. Okay, so let's solve this question now. Let me tell you, many students they solve this question by option elimination, because in this question you can notice some options are given to us, and by option elimination they solve this question. But we are going to solve this question without looking at the options, without option elimination, with complete analysis. Using the correct concepts we are going to solve this question. Okay, then at the end we are going to see which option is correct. Okay, is this clear? So let's read this question. You can see in this question some expression is given to us. This is a dangerous looking expression, yes or no? Xi, in this xi we are assigning p plus r multiplied by, this is the unary minus si plus u divided by w. So you can see this dangerous looking expression is given to us, and the question is asking that the following sequence shows the list of triples representing the given expression with entries missing for triples 1 3 6. You can notice that this is the sequence of triples for this expression, and you can see here 1 3 6. You can see these triple entries are missing. Okay, these triples are missing. You can see these triples are missing. The remaining triples are already given to us. Okay, now the question is asking that what are the missing entries. Okay, means what is the first entry, the triple. You can see, remember the positions they start from 0. Okay, so when I say triple one, or I can say first triple is basically actually this. Okay, I can say that triple number one, this is the triple number 0. Okay, so you can easily see what are the missing entries corresponding to position 1, position 3, and position 6. Okay, so let's solve this question. So this is the expression that is given to us, and we need to find what will be the triple representation corresponding to this expression. First, what you do, this expression is given in the high level language. First you convert this to 3 address code. Okay, when you convert this to 3 address code, then this question will become easier for you. Okay, so let's convert. First you convert this to 3 address code. Okay, so tell me, in the 3 address code, first what we are going to do. You can notice basically there are two operators. Look at the right side, there are two operators. One is multiplication, another is division, yes or no? Okay, and you can see they have same precedence. Multiplication, division, they have the same priority. Okay, and when they have same priority, then we go from left to right. So first we will do the multiplication, but before doing multiplication we need to do p plus r, yes or no? So remember, first we will do multiplication, but before that we need to do p plus r. Okay, so let me make that 3 address code. That is like this: t0, in this t0 I am putting p plus r. Okay, why I am starting the temporary variable by t0, why not by t1? Many students they start the temporary variables from t1. I'm starting the numbering from 0, because you can see in the triples also the positions are starting from 0. Okay, that is the reason I'm starting the temporary variables numbering from 0 onwards. Okay, so you can see in this t0 I'm putting p plus r. Then tell me what is the next thing you will do. Remember, we need to do this multiplication, because multiplication and division they have the same priority. So we will go from left to right. So we will do the multiplication. To do the multiplication, we need to do p plus r. Then we also need to do this. And here you can see this is the unary minus. Okay, so first we will do this SI. First we will calculate SI. So remember, in some temporary variable T1, I am going to put SI. Okay, this is the three address code. Then what I am going to do, in some temporary variable T2, I am going to put unary minus T1. Okay, yes or no? Now remember, this T2 is equal to minus SI, and this T0 is equal to P plus R. Now I can do the multiplication. So now in T3 I can put T0 multiplied by T2. Very easy. What is the next step? Now the multiplication is over. We have done the multiplication. Now we will do the division. Okay. So in T4 I can store U divided by W. Okay. Now this division is also done. Now we will do the addition. Okay. So you can see in T5 we are going to store this T3 plus T4. Okay, because in T3 we have the result of this multiplication, and in this T4 we have the result of this division. Okay, now this T5 has the result of RHS. This result of RHS is in the T5. So what we need to do next? Next we need to do this XI is equal to T5. Okay, yes or no? That's it. This is the three address code. Now what we need to do? This three address code we need to represent as a triple representation. Okay, so let's see now what will be the triple representation. So tell me about the first statement. For the first statement, what will be the triple representation? Tell me. Very easy. The operator is plus and the arguments are p comma r, and that is given to you. Very simple. This is already given to you. Okay, so actually without looking at this table also, let me make this triple representation without looking at this table. Of course we can also cross check with the table, but let me directly make the triple representation. That is operator argument 1 and argument 2. Okay, yes or no? In a triple representation we have three field. Okay, so let's see the positions. These are the positions: 0, 1, 2, 3, 4, 5, 6, and so on. Okay, so you can see these are the positions. Now let's see. Tell me about this first statement. In the triple representation, how to store it? Very simple. Operator is plus, arguments are p comma r. P r, that's it. Okay, this is the argument 2. Remember, in the triple representation there is no result field. Also we do not store the temporary variables. Yes or no? What about this next statement? Tell me. We have already seen in this lecture, we have already seen how to represent these index copy instructions. You can see this is also an index copy instruction. This instruction is indexed copy instruction. This instruction is indexed copy instruction. How to store these, how to represent these indexed copy instructions in triple representation, in the quadruple representation, all these concepts we have already seen in this lecture. You can watch it from the beginning. Okay, now let's see. So tell me, here we have the temporary variable T1. In this temporary variable T1 we are putting the value at the location s plus I. Okay, so this I already told you that in the triple representation, what will the operator? Tell me. For this instruction, what will be the operator? The operator is assignment bracket. Yes or no? Assignment bracket. Why? What is the reason? Because you can notice this bracket, this is on the right side of the assignment. You can notice, look at this instruction. Here, this bracket is on the left side of the assignment. So remember to distinguish this, whether this bracket is on the right side of the assignment or this is on the left side of the assignment. To distinguish this, we use these two different symbols. One symbol is assignment then bracket, and for this we will use bracket then assignment. Okay, yes or no? This we have already seen. Now let's see. So here you can see that the operator is basically assignment then bracket. What are the arguments? Arguments are s comma I. We do not have the result field, and also we do not store the temporary variables. Okay, so that's it. So remember, this is actually missing here. You can see this is actually missing. So let me tell you, here the operator will be assignment then bracket, and here it will be s, here it will be I. That's it. Very easy. Okay, let's see the next. What about this one? Here you have the operator is unary minus. Yes or no? Unary minus. This is the operator unary minus. And tell me, what are the arguments? The argument is T1. But remember, in the triple representation, whenever you need to refer to the result of some previous operation, then we do that by referring to the position. Okay, so very simple here. T1 means this position 1. Yes or no? So remember, the operator is unary minus. What is the argument 1? Argument 1 is T1, and T1 simply means that this position 1. Okay. And we are storing this to this temporary variable T2. But remember, in this triple representation, there is no result field. Also, we do not store the temporary variables. So that's it. So remember, argument 2 is not there. You can see in this instruction, there is only one argument, argument 1. Okay, there is no other argument. And the only argument, that is argument 1, that is T1. T1 means this position 1. Okay, so that's it. You can cross check. Okay, you can cross check. This is same as this. Now let's see the next. What about this next instruction? The operator is star. Then we have T0, T2. These are the arguments. T0 means position 0. T2 means position 2. Yes or no? Very simple. Remember, T0 is the result of this operation P plus R. And in the triple representation, to refer to the result of this operation P plus R, we will do that by referring to the position. Okay, so you can see that here in this instruction, the operator is star, and then T0 means position 0, T2 means position 2. Okay, this is the benefit. When I'm starting these temporary variables from 0, then this is the benefit. Okay, that is the reason I've started the numbering of the temporary variables from 0 onwards, because I know that in this triple representation, the positions are starting from 0. Okay, now let's see the next one. You can cross check. This was missing. You can see this is missing here. So let me write it here, that the operation is star and position 0, position 2. Now let's see the next one. Here you can see the operator is division. Okay, division is the operator, and the arguments are u comma w. Okay, you can cross check. That is same as this. Very good. What about the next? In the next instruction, you can see the operator is plus, and the arguments are t3, t4. T3 means position 3. T4 means position 4. You can cross check. This is same as this. Okay, very good. Now let's see about the last line. Only this is remaining. Okay, this last line, this is remaining. What will happen for this line? Basically, what will happen for this instruction? Okay, so let me only tell you for this instruction, like focus only on this instruction, xi t5. Okay, yes or no? Just focus on this instruction. Okay, let's see in the triple how to store this. Actually, this we have already seen. How to store, how to represent this indexed copy instruction. This is the indexed copy instruction. How to store, how to represent this indexed copy instruction in the triple representation. Okay, we have already seen, but let's see here. So I told you, if you remember, that for to represent this instruction, we need two entries. Okay, what are the two entries? Tell me. In the triple representation, to represent this instruction, we need two entries. What are the two entries? Tell me. Notice what is the meaning of this instruction. Here, this value of T5 we are storing at the location x plus I. Yes or no? So remember, this value of T5 we are storing at some location. So first you compute the location. So remember, there will be two entries in the triple representation corresponding to this instruction. And the first entry, that will be for computing the location. Okay. So what we are going to do, remember, we are going to compute the location. Okay, this location we are going to compute, and let's store this in some temporary variable t6. Okay, very easy. So you can see we will compute the location and we will store it in some temporary variable t6. And then what is the second thing? Second thing is very easy. In this location, now this t6 has the location. In this location, we will store the value t5. That's it. Okay, so very easy. Now let's see what will be the first entry. Let's see what is the numbering here. You can see 6. Okay, so the position number 6 and position number 7. Because I told you that for representing this instruction, we need two entries in the triple representation. Okay, so tell me what will be the first entry? First entry will correspond to this. So tell me what is the operator here? The operator is bracket then assignment, because remember this bracket is on the left side of the assignment. So you can see this bracket is on the left side of the assignment. So this is the operator. What are the arguments? Look at just this entry. So what are the arguments? Arguments are x comma I. That's it. Okay, we do not have the result field. We do not store the temporary variables. Very simple. Now let's see this T6 equal to T5. Here you can see the operator will be assignment. Assignment is the operator. And remember, this will be argument 1, this will be argument 2. So argument 1 will be T6. T6 means position 6. And argument 2 will be T5. T5 means position 5. That's it. I hope you understood. So remember, this will be your last two positions, last two entries. Okay, so you can see this entry, this position number 6, this was missing. So I can write it here. That operator is basically bracket assignment, then x comma I. Okay, that's it. This is the answer. And you can see this last entry also, you can cross check. This is same as this. Okay, so I hope you understood this complete explanation. Okay, so remember the 6 entry and the 7 entry we have already seen. What is the 6 entry? That is bracket assignment, then x, then I. And what is the 7 entry? That is assignment, the 7 entry, that is assignment 6 5. Okay, so that's it. This is your answer. Is this point clear? Please tell me. So now you can see which option is correct. The question is asking what are the missing entries for position 1, position 3, position 6. What are the missing entries? So you can see in the position 1, what was the missing entry? That is operator was assignment, then bracket. Okay, yes or no? Assignment, then bracket. So you can see in the position 1, the operator is assignment, then bracket. Here, bracket, then assignment, this you can eliminate. Assignment, then bracket, bracket, then assignment, this you can eliminate. Okay, so remember, option A comma option C, these are still pending, because yes, this is also correct. Both are basically correct. Yes or no? But the operator is, and then S comma I, you can easily see. So this is the position 1. What about the position 3? That is star position 0, position 2. You can see star position 0, position 2. Still you can see option A comma option C, both are remaining, both are same. Okay, in the position 1, position 3. Let's see the last position. What was the sixth position? That is bracket, then assignment, x comma I. Okay, so you can easily see, yes. So option A is correct. Okay, you can see this is wrong. Why this is wrong? Here you can see the mistake is, instead of this 5, actually it will be I. Okay, yes or no? It will be actually I. You can easily notice here. That's it. So this is the gate 2020. What was this question? 2024 or 2025? So this was gate 2024 question. We have done the complete analysis of this question. I hope you understood the complete analysis of this question with the correct concepts. Did you crystal clearly understood? Let me know. Did you understand? Let me know. Let's solve gate 1992 question. Write 3 address intermediate code in the quadruple representation for the following Boolean expression in the sequence as it would be generated by the compiler. So this expression is given to us in the high level language. We need to convert this to 3 address intermediate code. Also, we need to find the quadruple representation. Okay. The question is saying assume the usual rules of precedence of the operators. What are the usual rules of the precedence of operators? So what this line means, let me know. Usual rules of precedence of operators. You can notice we already know that AND operator has more priority than OR operator. Okay, so you can see here, notice here that we have OR operator, also we have AND operator. So tell me, first will you do this OR operator, or first you will do this AND operator? So first we will do the AND operator. Yes or no? This is what the question is saying, that assume the usual rules for precedence of operators. We know that AND operator has more priority than OR operator. So basically here, this is what we will do. This is what we will do. Then we will do the OR. Okay. Is this clear? Very simple. Now let's see. So this is the expression and this is in the high level language. First we need to convert this expression to 3 address code. Then we will find what will be the quadruple representation. Also we will find the triple representation also for variation. Okay, for our practice. So first to find the 3 address code. Tell me, already we know that we will do this, we will do this. Okay, yes or no? then we will do the OR. At the end, we will do the OR. So tell me, what is the three address code? That is very simple. T0. In T0, we can put A plus B. Okay, this A plus B we will compute and we will put in T0. This C plus D we will compute and we will put in T1. Then you can see, then we have this. Then we can have T3. This another temporary variable we have, and in this we will put T0 greater than T1. Yes or no? So notice one thing, that this T3, this temporary variable is basically a Boolean variable, because remember the result of T0 greater than T1, the result of this either will be 0 or 1. I can say the result will be either true or false. So remember this T3, either it will be 0 or it will be 1. So this is a Boolean temporary variable. Okay, this T3 is a Boolean temporary variable. Okay, very simple. Now let's see. Then you can see what we will do. Then we will do this A greater than C. Okay, in T4, here you have T2. Okay, T0, T1, T2. This is T2. Next you have T3. In T3, you can put A greater than C. Again, this T3, this is also a Boolean temporary variable. Okay, next you can see in this T4, I can put B less than D. So this B less than D, I can put in T4. Then we will do this AND. In T5, I can put this T3 and T4. Okay, yes or no? Very easy. Then what we are going to do? Then finally we are going to do this OR. Okay, so in T6, we can put OR between whom? You can see OR between T2, because remember T2 has this result and T5 has this result. So I can say that T2 or T5. Okay, is this point clear? Because you can notice that this result is present in T2 and this result is present in T5. Very easy. So this is the three address code that we got. Now, can you find what will be the triple representation and what will be the quadruple representation? Tell me. So let's see what will be the quadruple representation. In the quadruple representation, we have four field: operator, argument 1, argument 2, and result. Okay. These are the position numbers: 0, 1, 2, 3. Total, you can see 0, 1, 2, 3, 4, 5, 6. Okay, so you can see 4, 5, 6. Okay, so like this. Now let's see. Tell me, for this instruction, how to represent in the quadruple representation? The operator is plus. Plus is the operator, arguments are a comma b, and the result is T0. That's it. What about this next one? The operator is plus. What are the arguments? Arguments are c comma d, and the result we are storing in T1. What is the operator for the next instruction? For the next instruction, the operator is greater than. This is the operator greater than, and you can see the arguments are T0, T1, and the result will be stored in T2. This is the quadruple representation. Okay, next you can see the operator is greater than, and the arguments are a comma c, and the result is T3. Let's see the next. The operator is less than. The arguments are b. Here, this will be b. Okay, so the arguments are b comma d, and the result is stored in T4. What about the next? The operator is what? The operator is AND. Yes or no? Here you can see this is the operator AND. So AND operator, and the arguments are T3, T4, and the result we are storing in T5. Very simple. Okay, for the last you can see the operator is OR. For the last, we can see that the operator is OR, and the arguments are T2, T5, and the result we are storing in T6. So this is the quadruple representation. I hope you understood. Can you also find the triple representation? Just for practice sake, the question is not asking, but just for practice, let's find the triple representation also. In the triple representation, we only have three field. These are operator, argument 1, argument 2. There is no result field. We do not store the temporary variables. Okay, very simple. And you can see these are the positions: 0, 1, 2, 3, 4, 5, 6. Okay, so these are the positions. Now tell me, in the triple representation, how this instruction will be represented? So the operator is plus and the arguments are a comma b. Very easy. What about this instruction? The operator is plus and the arguments are c comma d. Very easy. Very good. Now let's see this one. Here you can see the operator is greater than. And what are the arguments? Arguments are t0, t1. But remember, in the triple representation, we refer the result of previous operations by their position, not by the temporary variables. So you can see the operator is basically greater than. These are the arguments t0, t1. T0 means position 0, t1 means position 1. Okay, very simple. That is the reason. Remember, in the triple representation, these positions they start from 0. That is the reason these temporary variable numbering I have started from 0. You can see the temporary variables numbering, you can see that I have started from 0 onwards. Okay, so that I can easily create the triple representation, because you can see t0 means position 0, t1 means position 1. Okay, let's see the next. Here you can see the operator that is greater than and the arguments are a comma c. Let's see the next. Here the operator is less than and the arguments are b comma d. Okay, what about the next? The operator is and what are the arguments? The arguments are t3, t4. Remember, t3 is the position 3 and t4 is the position 4. Very good. Now let's see the next one. For the last instruction, the operator is or, and you can see the arguments. These are t2, t5. Remember, t2 means position 2, t5 means position 5. Okay, so this is the triple representation. Very easy. Now tell me about the indirect triple representation. There is something called indirect triple. So let me know what we need to do to make indirect triple representation. Very simple. To make the indirect triple representation, we need triple representation that we already have. Also, we need execution order. Yes or no? In the indirect triple representation, we separate the execution order from the triples. So these triples will be as it is. Also, we need execution order. Okay, and to to represent the execution order, we need a array of pointers. So this is the array of pointers. We call it instruction array. And this is the array of pointers. Okay, you can see this will point to the triples. So very simple, like this. Okay, so very easily you can see. Okay, so that's it. So you can notice that this instruction array we have. Okay, and this instruction array will tell you about the execution order. Because remember, in the indirect triple representation, we separate the execution order from the triples. Okay, so the triples are separate and the execution order is separate. And to represent the execution order, we have this instruction array. Okay, this is an array of pointers. This will point to the triples. Okay, very simple. And remember, the benefit of indirect triple, what is that? That is, if you need to rearrange the code, if you need to move around the instructions, if you need to rearrange the code, then remember, you do not have to bother the triples. Okay, this triple, basically this will be unaffected. You just need to change the execution order, because we have separated the execution order from the triples. Okay, this is the benefit of indirect triples, that in the indirect triples, rearranging the code, or I can say moving around the instructions, that becomes easier. Okay, so that's it. This is the complete analysis of this gate 1992 question. I hope you understood. Let's solve gate 1989 question. Is the following code template for if then else statement correct? If it is not correct, then correct it. So this is a subjective question. So this if then else statement is given to you. The question is saying, this is the statement. If expression then statement 1, means if this expression is true, then we will execute this statement 1. And if this expression is false, then we will execute statement 2. So you can see, if this expression, then statement 1, else statement 2. Okay, this is a high level language construct. Remember, this we use in the high level language. And the question is asking, what is the correct code template in the intermediate language? Okay, so let's see. First of all, let's decide whether this template is correct or not. Okay, remember, this is our high level language construct. high level language construct, or I can say high level language code. Okay, and remember, this is the intermediate language, or I can say this is the intermediate translation. So you tell me, this template, is this correct or not? Here you can see in this template we have code for expression. Okay, for this expression, remember, first we need to calculate whether this is true or false, yes or no. Okay, if this is true, if this expression is true, then we will execute statement 1. If this expression is false, then we will execute statement 2. This is the meaning, very simple. Okay, so you can easily see what is the meaning. First of all, let me write it here. What is the meaning? The meaning is basically that if I can say this expression, you have this expression. Okay, first we need to calculate this expression. Okay, the question is saying that there is a code for this expression. Okay, and the result is stored in E. Okay, so first you will calculate this expression. After computing this expression, the result you are storing in E. Okay, so this expression we will compute. This expression we will compute. Okay, you can see code for expression. So first we will compute. Then result we are storing where? Then result is stored in E. Okay. Now remember, if this E, you already know, if this E is true, if this is true, then we need to execute statement 1. Okay, then we need to execute statement 1. And if this E is false, then we need to execute statement 2. This is the meaning. Okay. Are we doing the same thing here? You can notice the result of this expression that is in E, and the question is saying that E greater than 0 indicates true. Okay, so please understand that when I say E is true, that is indicated by E greater than 0. So E greater than 0, this will indicate true. Now we are saying that branch on E greater than 0 means when E is true, because E greater than 0 means true, branch on E greater than 0 to L1. Okay, so this template is saying, what this template is saying, this template is saying that when E is true, then branch to where? Then branch to L1. Okay, then branch to L1. And what we have on L1? On L1 we have statement 2. But actually we should execute statement 1. Yes or no? When E is true, then we should execute statement 1. When expression is true, we should execute statement 1. When E is true, we should execute statement 1. But actually this template is saying that when E is true, then branch to L1, and this L1 is basically your statement 2. Okay, this L1 has code for statement 2. So definitely this template is wrong. Yes or no? Okay, so I can say this template is wrong. Very simple point. So I can say wrong template. Okay, is this clear? Now the question is asking, if it is wrong, then correct it. Okay, so find the correct template. So now let me tell you what will be the correct template. That is very easy. When E is true, then you execute the statement 1. Otherwise, you execute the statement 2. So here, remember the correct template. Let me write here. Correct template will be like this. You have code for expression, that is fine. Okay, there is a code for expression. All these things are fine. Okay, so you can see code for expression, then the result is stored in E, and E greater than 0, that indicates true. Okay, so basically we just need to see, we need to correct this, correct version. What will be the correct version of this? That is what we need to see. Okay, so what we are going to do, very easy. Remember, branch on E greater than 0. E greater than 0 means E is true. So when E is true, then you branch to where? You branch to some statement L1. Okay, some statement L1. But remember, on this L1 we will put the code for statement 1, because when you have E greater than 0 means when E is true, then we should execute statement 1. So please understand, at this L1, at this level L1, remember, we need to put the code for statement 1. not the code for statement 2. Okay, yes or no? So code for statement 2, that is actually wrong. We should put code for statement 1. Okay, so if e is greater than 0, then you jump to L1. And tell me, if this e is not greater than 0, means if e is false, then what we need to do? Then we need to execute statement 2. Okay, yes or no? So then we need to execute statement 2. Code for statement 2 you can put here. You can put the code for statement 2 here. Okay, so you can see like this. After code for statement 2, we also remember, after executing the statement 2, we cannot execute statement 1. So remember, we also need to jump, or I can say branch to L2. Okay, and this L2 is somewhere here. This is the idea. I hope you understood this point. So remember, this will be the first step, this will be the first instruction, this will be the second instruction, this will be the third instruction, this will be the fourth instruction, and this will be the fifth instruction. So this is the correct template. I hope you understood this. Very simple. In this template, we are saying that if E is true, then you jump to L1. Okay, and L1 has code for statement 1, because if expression is true, then we need to execute statement 1. But remember, if this E is false, then we need to execute statement 2. So we will have code for statement 2. But remember, after executing statement 2, we cannot execute statement 1. So after executing statement 2, we need to basically branch outside. Okay, branch to outside, or I can say you branch to L2. This is L2. So that's it. Remember, after statement 1 also we will go to L2, and after statement 2 also we will go to L2. Okay, L2 can be something, the next statement. L2 can be the next statement. So this is the correct template. I hope you understood. Very simple question. So this is a subjective question. I hope you understood the solution. Remember, this branch is basically the go to statement. Okay, so for go to statement, for jump, these alternative words are used. Either you can say jump statement, or you can say branch statement, or you can say go to statement. These are different words used for the same thing. Okay, we can have conditional jump, unconditional jump. Similarly, conditional branch, unconditional branch, conditional go to, unconditional go to. So remember, these are synonyms of each other. Okay, let's all get 2024 set 1 question. Let's all get CS 2024 question based on control flow graph. So consider this pseudo code. Which one of the following options correctly specifies the number of basic blocks and the number of instructions in the largest basic block respectively? These are the options given to you: 6,6677776. Okay, so remember, for this given program, we need to find the control flow graph, or I can say that we don't need to find the control flow graph. We just need to find what are the basic blocks, how many basic blocks are there, and what is the number of instructions in the largest basic blocks. Okay, so let's see. Let me tell you, to solve this question, all the concepts that you need, those you can learn from this lecture. So basically, on the Go Classes YouTube channel, you can find this control flow graph Go Classes. On the YouTube, you can search control flow Go Classes. Okay, control flow graph Go Classes. You can search on YouTube. This video will come, and watch this lecture. In this lecture, all the concepts you will understand to solve this question, or any question similar to this, you can easily solve after watching this lecture. So remember, this is control flow graph CFG complete lecture, basic blocks, leaders, loops. Okay, everything we have discussed in this lecture. Now, let's come back to this GATE 2024 question. So this program is given to us, and we need to find how many basic blocks are there. To find the number of basic blocks, what you will do? First, you will find what are the leaders. Yes or no? So let's find what are the leaders. Then we can easily find what will be the basic blocks. Remember, the number of blocks, the number of basic blocks is equal to number of leaders. Okay, so first you find what are the leaders. How to find the leaders? There are three rules. What are the three rules? Remember, the first instruction of the program, that is a leader. This is the rule number one. What is the second rule? The second rule is that for any jump instruction, conditional or unconditional, for any jump instruction, the target is a leader. Also, what is the rule number 3? That is the instruction immediately following the jump instruction, that is also a leader. Okay, so basically there are only 3 rules to find the leaders. And also number of leaders is equal to number of basic blocks. Okay, so tell me, what will be the leaders here? You can apply the rules. Let's apply the rule number 1. Rule number 1 says that in the program, the very first statement is a leader. Okay, so remember, this is a leader. I am writing that this is a leader. Okay, very simple. You can say this is leader number 1, or you can simply say that this is a leader. Now, what is the next leader? Or I can say, what are the other leaders? You can see this is because of rule number 1. Rule number 1 says that in the program, the very first instruction, that is a leader. Okay, so this is the very first instruction, this is a leader. Next, next rule says that for any jump instruction, whether it is conditional jump or unconditional jump, for any jump instruction, for any branch instruction, the target is a leader. Here you can see the target is L11. So this L11 will be a leader. Okay, this L11, this is also a leader. Also, you can notice this is also a jump instruction. So the target is a leader, means L4 is a leader. This is also a leader. Next, for this jump instruction, the target is a leader, means this L3, this is also a leader. Okay, what are the other leaders? You can see we have seen the rule number 1. The very first instruction is a leader, so L1 is a leader. Next, you can see this L11, L4, L3. These are the target of jump instructions. So these are also the leaders. Next, remember, for any jump instruction, conditional or unconditional, for any jump instruction, the very next instruction is also a leader. So this L10 is also a leader. Also, because of this jump instruction, L13 is a leader. And because of this jump instruction, L15 is a leader. Okay, is this clear? So remember, these are also leaders. So this L10, this is a leader. L13, leader. And also this L15, this is a leader. Okay, is this clear? So tell me, total how many leaders are there? That's it. We have applied rule number 1, rule number 2, rule number 3. So tell me, total how many leaders are there? The number of leaders you can count, that is 1, 2, 3, 4, 5, 6, 7. So total we have 7 leaders. And remember, the number of basic blocks is equal to number of leaders. Number of basic blocks, that is equal to number of leaders. Okay, so here I can say number of basic blocks, that will be equal to 7. So number of basic blocks will be 7. Now let's see what are the basic blocks, and let's see what will be the largest basic block, because the question is asking you find the number of basic blocks, also you find what is the number of instructions in the largest basic block. Okay, so already we have found the leaders. So you can see this L1 was a leader. Next, you can see L3, L4, these are leaders. Let me mark. Next, you can see L10, L11. Next, L13, L15. Okay, these are the leaders. Now let's find what will be the basic blocks. Okay, basic blocks are very easy. From any leader to the next leader, but don't include the next leader, that will be the basic block. Okay, remember here I can say that from L1, just start from the leader. This is your leader L1. You start from here till the next leader, but don't include the next leader. Okay, so this will be your basic block. So very simple point here. So here I can say that from this leader to the next leader, but don't include the next leader, that will be your basic block. So remember, this is going to be a basic block. Okay, let's call it basic block 0. Okay, or you can call it basic block 1, that's fine. Now let's see the next. Again, you can see from this leader to the next leader, but don't include the next leader, because remember, in one basic block you have only one leader. Every basic block has only one leader. One basic block, each basic block has one leader. That is the reason number of basic block is equal to number of leaders. So remember here, from this leader to the next leader, but don't include the next leader. So you can see this will be a basic block. Let's call it basic block B2. Okay. Next you can see, start from this leader till the next leader, but don't include the next leader. Okay. So this will be your basic block, because remember, in one basic block there is only one leader. Number of basic blocks is equal to number of leaders. Okay, so you start from a leader, okay, till the next leader, but don't include the next leader. Okay, this will be your basic block. Let's call it basic block B3. And I think this will be the largest basic block in terms of number of instructions. You can see how many instructions you have: 3, 3, 6. Okay, total this has total 6 instructions. So you can stop here because this will be the largest basic block, and this has 6 instructions. So number of basic blocks, that is 7, and the largest basic block has 6 instructions. Okay. So for this question the answer will be 7 comma 6. The answer will be option D for this question. Okay. But anyway, let's find what are the basic blocks, from where to where we have the basic blocks. Let's find the next basic block. Start from a leader till the next leader go, but don't include the next leader. Okay, so remember this will be a basic block. Let's call it basic block 4. Next, let's start from this leader. Okay, keep going. From this leader you start, keep going, but don't include the next leader. Keep going till the next leader, don't include the next leader. This will be your basic block 5. Okay, next you can see here, start from this leader, keep going, don't include the next leader. Okay, keep going, and this will be your basic block 6. And finally, the last basic block that we have, that has only one instruction. So this is the last basic block. This is basic block 7. Okay, is this clear? So total we have 7 basic block, and in the largest basic block the number of instructions, that is 6 instructions. Okay. Now also let me ask you, if I make the control flow graph, how many edges will be there and how many nodes will be there? So please understand, here you can notice that 7 basic blocks are there. If I ask you number of basic blocks, then that is 7. Okay. And if I ask you, in the control flow graph, how many nodes will be there? Okay, now you tell me, in control flow graph, let's make a control flow graph. In that control flow graph, what will be the number of nodes and what will be the number of edges? Okay, what will be the number of nodes? What will be the number of edges? Remember, in the control flow graph, when you calculate the number of nodes, then there is a special entry node, also a special exit node. But those are not basic blocks. In our lecture, we have already seen this. This lecture I uploaded 1 year ago, and let me tell you, many students they made this mistake in GATE 2025. In GATE 2025, this question came. It was asking number of basic block, but students also added entry node, also exit node. But you can watch this lecture. This lecture I took 1 year before GATE 2025 exam. This lecture I uploaded on the YouTube 1 year before GATE 2025 exam. And let me tell you, you can watch this lecture. Here I have clearly said, with help of 2 examples, I have mentioned it very clearly, that basic blocks and these, remember, these entry and exit node, these are a special node in the control flow graph. These are not basic block. So please understand that in the control flow graph we have entry node, exit node. These are a special node in the control flow graph. These are not the basic block of the program. Basic block is the property of the program. You have a program, in that program you calculate the number of basic block. But remember, the control flow graph has 2 special node, entry node and exit node. These are special nodes in the control flow graph. These are not basic block of the program. Okay, and this I clearly have mentioned in this lecture. You can watch it. Okay, so let's come back to this question. Let's make the control flow graph. In the control flow graph, what will be the number of nodes and what will be the number of edges? So you already know there will be an entry node, there will be exit node. These are 2 special nodes in the control flow graph: entry node, also exit node. Okay, and You can see from the entry node there will be only one outgoing edge, and that will be to the block containing the first instruction. Okay, so you can see our basic block 1, we have basic block b1. This is the basic block b1. It has instruction 1 comma 2. Okay, remember from the entry node always there will be a single outgoing edge, and that will be to the basic block containing the very first instruction. Okay, very simple. This concept we have already seen in this lecture. Now let's see the next we have basic block b2. B2 we have, in this we only have one instruction, that is instruction number 3. Okay, notice one thing, that from b1, in the b1 what is the last instruction? Notice in the b1, in the block b1, in the basic block b1, the last instruction is a simple instruction. This is not a jump instruction. The last instruction is not a jump instruction, so remember there will be only one edge from b1 to b2. Okay, so b2 has only one instruction. Then we have b3. B3 has many instructions. B3 has how many instructions? You can see 4 to 9. Okay, 4 to 9, these instructions, these are in the basic block b3. And remember one more thing, that in this block b2, the last instruction is a simple instruction, it is not a jump instruction. So I can say from b2 to b3 there will be a edge. Okay, that's it. Next you can see b4. B4 has only one instruction, that is instruction number 10. Then b5 has two instructions. B5 has instruction 11, 12. Then B6 has 13, 14. And then B7 has only one instruction, that is 15. Now let's see what will be the edges. Okay, so let's see from every basic block how many outgoing edges will be there. We have already seen b1, b2, because in this b1 also, in this b2 also, the last instructions are not jump instructions. These are simple instructions, not jump instructions. So there will be only one outgoing edge from b1 comma b2. Okay, from b1 to b2 and from b2 to b3. But look at this b3. In this b3, the last instruction is a conditional jump instruction. Yes or no? It is a conditional go to instruction, so there will be two outgoing edges. Yes or no? This last instruction of b3 basic block, that is a conditional jump instruction, so there will be two outgoing edges. One edge will be to the basic block containing L11. Okay, so you can see from b3, one edge will go to the basic block containing instruction 11, and also one edge will go to the next basic block, because this is a conditional go to. So if this condition satisfies, then we will go to L11, and if this condition does not satisfy, then we will go to L10. Okay, so you can see like this, very simple. So that's it, we have done the b3 also. What about b4? In b4, the last instruction is a simple instruction, so there will be only one outgoing edge from b4 to b5. Okay, from b4 to b5 there will be one edge, like this. Okay, what about b5? You can see in this b5 also, the last instruction is a conditional jump instruction. So if this condition becomes true, then we will jump to L4. Okay, so you can see from b5, if the condition becomes true, then we will jump where? We will jump to L4. L4 is in the basic block b3. Okay, very simple. And remember, if this condition does not satisfy, then we will go to the L13. Okay, then L we are going to go to L13. Very simple. Now let's see basic block B6. In the basic block B6 also, the last instruction is a conditional jump instruction. So there will be two outgoing edges. You can see if this condition satisfies, then we will jump to L3 from B6. You can see from B6, if this condition satisfies, then we will go to L3, basic block containing instruction L3. Okay, like this. And you can see that if this condition does not satisfy, then we will go to L15. Okay, that's it. And what about this basic block B7? In this basic block B7, we have simple instruction, which is not a jump instruction. So there will be only one outgoing edge to the exit node. Okay, that's it. One more thing I want to ask you. Tell me, in this whole program, you tell me from which basic blocks we can go to the exit node, or I can say which are the instructions from where we can go to the exit node. Tell me, which are the instructions in this whole program, which are the instructions from where we can exit. So you can notice this is the only instruction L15, this is the only instruction from where we can exit, because please understand that these are normal non-jump instructions. Okay, like from this instruction you will go to the next instruction, after this instruction you will go to the next instruction. Okay, so you cannot exit. And you can notice this is jump instruction, but if this condition satisfies, then we will go to L11, we are not going to exit. And if this condition does not satisfy, we will go to L10, so we are not going to exit. You can notice similarly this is a simple instruction, after this instruction we will go to the next instruction. And look at this jump instruction, if this condition satisfies, we will go to L4, and if this condition does not satisfy, we will go to L13. So you can notice that there is only one instruction from where we can go to exit node. So you can see there is only one edge to the exit from block B7, from the basic block B7. Okay, so that's it. You can see that we have seen outgoing edges from every basic block. So tell me, what is the number of edges? Number of edges. What that is? You can calculate the number of edges. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of edges will be 11. Okay, so that's it. I hope you understood this. So remember, the number of edges will be 11. And what will be the number of nodes? That will be number of basic blocks plus two special nodes, one entry, one exit. So you can see there are total 9 nodes in the control flow graph. And remember, the basic blocks are only 7, because these entry node, exit node, these are special nodes in the control flow graph. These are not basic blocks. Basic block is the property of the program. In the program you find how many basic blocks are there. Okay, so remember, exit node and this entry node, these are special nodes of the control flow graph. These are not basic block. So number of basic block, that is 7. Number of nodes in the control flow graph, that is 9. Number of edges is 11. Okay, so that's it. This is the complete analysis of this question. I hope you understood. Let's solve this gate 2025 question. We have 3 address code. This is the 3 address code sequence. We need to find the number of basic blocks. So this is a very easy question. We just need to find the number of basic blocks. Let me tell you, to solve this question, all the concepts that you need, like what is a basic block, how to find the number of basic blocks, how to find the basic blocks in a program. So all the concepts needed to solve this question, you can learn from this lecture. So on the YouTube, you can search control flow graph go classes. This lecture will be there, control flow graph CFG complete lecture. Okay, you can watch it. In this lecture, I have done the discussion of control flow graph, basic block, leader, loops in a control flow graph, entry node, exit node. Basically, the complete discussion I have done in this lecture. Okay, so once you watch this lecture, you can easily solve this GATE 2025 question. You can also solve many similar questions in the GATE exam. Okay, now let's solve this question. The question is asking for number of basic block. Let me tell you, before we solve this question, in this question, actually many students, they made mistake. Many students, they included entry node, exit node in the counting of basic block. But remember what I told you? I told you that entry node, exit node, these are special node in the control flow graph. These are not basic blocks. In this lecture, I already told you, let me tell you, this lecture I uploaded 1 year before GATE 2025 exam. This lecture I have uploaded 1 year before GATE 2025 exam. And in this lecture, let me tell you, specifically I have mentioned 2 times with help of 2 examples. 2 times I have mentioned this point that basic blocks and entry node, exit node, these are separate things. Entry node, exit node, these are special nodes in the control flow graph. These are not basic block. Basic block is property of the program. From the program, you can find the basic block, and then from the basic block, you can create the control flow graph. When you create the control flow graph, then entry node, exit node, these are special node in the control flow graph. These are not basic block. You can see when you watch this lecture, you will see this slide, you will see. Okay, you can see here I have clearly mentioned that for this program there are, you can notice there are four basic block and there are six node in the control flow graph. So please understand, basic blocks are only four, but the number of nodes in the control flow graph, that is six, because entry node, exit node, these are not basic block, these are special nodes in the control flow graph. You can notice also in this same lecture. Okay, in this same lecture you will see another example. This another example I have put. Okay, here also you can see number of basic block is 5 and the number of nodes in the control flow graph, that is 7. Okay, you can see number of basic block 5, number of nodes in the control flow graph, that is 7. Because this entry node, exit node, these are special nodes in the control flow graph, these are not basic block. Basic block is the property of the program. Okay, so from the program you can find the basic blocks. I hope you understood. Okay, also let me tell you, after the gate 2025 exam I made this video. Okay, so this basically this short you can find on the YouTube. You can search gate 2025 basic block on the YouTube, you can search this. So you will see this short. I made this short immediately after the gate 2025 exam, and here I was talking about the same point, that exit node, entry node, these are special node in the control flow graph, these are not basic blocks. Okay, the same point I have discussed in this short also. So again I'm telling you that if you have any confusion, any misconception, or any misunderstanding, then remember this complete lecture you can watch on the YouTube. You can search control flow graph go classes. Okay, now let's solve this question. So this three address code is given to us. We need to find what is the number of basic blocks. Remember, to find the basic blocks you will first find the leaders. Yes or no? Number of basic blocks is equal to number of leaders. Okay, so very simple point. Let's find what will be the basic blocks here, or I can say what will be the number of leaders here. So first you find the leaders. And how to find the leaders? In a program, how to find the leaders? There are three rules. The first rule is the very first instruction is a leader. The second rule says that for any jump instruction, conditional or unconditional, for any jump instruction, the target is a leader. And what is the third rule? For any jump instruction, the next instruction is a leader. Okay, so very simple. These are the three rules. So you can see, according to rule number one, you can see that the first instruction, the very first instruction in the program, that is a leader. So remember, this very first instruction, this is a leader. Okay, now what is the rule number two? That says that you find the jump instructions, conditional or unconditional. Okay, you just find the jump instructions. So you can see this is a jump instruction, this is a jump instruction, this is a jump instruction. Okay, we don't have any unconditional jump. All are conditional go to. This is conditional go to, this is also conditional go to. Okay, so you find the target. The target will be a leader. So you can see this 1003, this is a leader. Next you can notice this 1002, this is also a leader. Next you can see this 1013, this is also a leader. Okay, so remember these are the leaders. Is there any other leader? Yes, there is any other leader also. You can see rule number 3. For any jump instruction, the next instruction is a leader. So you can see this is the jump instruction. For this jump instruction, remember the next instruction is a leader. So remember this 1010, this is also a leader. You can see this is also jump instruction. Conditional or unconditional, whatever jump instruction you have, the next instruction will be a leader. So you can see this 1012, this is also a leader. And this is also jump instruction. So the next instruction is a leader, but we don't have any next instruction, so don't worry about it. So I can say that's it. So these are the leaders. I think this question, this 2025 question, I think this as it is this question without any changes, I think we have done in this lecture. I think this as it is question, this gate 2025 question as it is without any changes, the same question I think we have done in this lecture. If you have watched this lecture, I think this gate 2025 question as it is you will find in this lecture. Okay, you can check it out. We have already done this basically this gate 2025 question 1 year before gate 2025. We have done this question in this lecture. Okay, you can check it. Anyway, so let's solve this. Let's continue. So you can see what are the number of leaders? Tell me here. The number of leaders you can see 3 leaders here, then 3 here. So number of leaders is 6. And if number of leaders is 6, then remember number of basic blocks is equal to number of leaders, and that is equal to 6. Okay. Don't say 8, because when you make the control flow graph, then in the control flow graph, number of nodes will be 8. Because entry node, exit node, these are a special node in the control flow graph. These are not basic blocks. So remember, let me write it here. In the control flow graph, the number of nodes will be 8. The number of nodes will be number of basic blocks plus two special node, entry node, exit node. So the answer, remember, for this question, the answer will be 6 only, because the question is asking number of basic blocks. If the question asks you number of nodes in the control flow graph, that will be 8. But because the question is asking number of basic blocks, so remember the answer will be 6 only. Okay. And you can just watch this lecture as I told you. This I uploaded 1 year before the GATE 2025 exam, and this as it is, this question, this GATE 2025 question, as it is, you will find in this lecture. Okay. So that's it. We have done the analysis of this question. So I hope you understood this question. Okay. Thank you, everyone. I hope you loved this session. For every question, we have done the complete analysis. Please share your feedback with me in the comments. Okay. And also remember, this GATE 2025 question, 1 year before coming to the GATE 2025, I have already solved it in this video. Once you watch this video, you will find this question, you will find. Okay. So that's what I'm telling you, that as it is, this question you will find in this lecture. And that is a very good thing, that questions in the GATE exam are coming, and before coming to the GATE exam, they are present in the Go classes lectures, in the test series, in the weekly quizzes. And this happens many times. Okay. This has happened in the last 2-3 years. Okay. Ever since we started Go classes, this has happened many times, that many GATE exam questions, when they come to the GATE exam, before that, those questions you will find in the Go classes lectures, test series, weekly quizzes. Okay. Okay. Thank you, everyone. Please share your feedback. Thank you.